Okay, so in this video, I would like to cover the just kind of overview of what we've done for the last two units, the two small units on visual and perception paradoxes and infinity and infinitesimal paradoxes. So let's go over the notes. Okay, so there are very few topics here. We talked about rope around the earth. This was a simple geometry calculation using circumference and radius of Earth, but he gave a very unintuitive answer. So sometimes gut feelings give you wrong answer. So sometimes computing leads you to the right answer if the formula is known. Curry paradox is the paradox with pieces of triangle. It looks something like this. Then you can kind of rearrange it. So somehow there was a gap at a certain spot. It was a paradox that looked like moving around an area changed the size somehow. The trick to that paradox was that, these two pieces of triangles does not have the same slope. So an exaggerated version of the picture, one triangle looked like this, and then the other triangle looked kind of like that. So something like this. Like, I don't remember the exact shape, but it wasn't a true triangle. One was dented in, and the other one was jetting out. So there wasn't actually any area that was gained or lost. It wasn't a true triangle that was shown. It just looked like it. The slight difference in the bulge and the dent was very hard to see just from the picture. And then we did a lot of examples of how perception and what we expect changes what we perceive. So there was a lot of visual illusions on different gray shadings that where one looked lighter than the other, or different colored dresses depending on how your brain interpret how shadowy or bright the picture is. And there was an audio clip of either heads or tails that came differently depending on how your brain interpreted it. We looked at a lot of different Escher drawings and Penrose triangles where if you look at pieces of the picture or drawing, if you focus locally, it makes sense. But if you look at overall, it didn't make sense. We carefully looked at Mobius strips and its properties, how it has only one side and there's only one edge. And there was a homework problems and worksheet problems on what happens if you cut it in different situation. So you should be aware of those things. Try them out if you haven't done it already. So that was visual and perception paradoxes, and this week we talked about infinity and infinitesimal paradoxes. We spent quite a bit of time talking about Grand Hilbert Hotel, where we have an infinite hotel with infinitely many rooms, and they're all occupied. And if new visitor comes, sometimes it's possible to rearrange the room so that you could accommodate the new guests and do not have to kick anybody out of the hotel. So you should be prepared to answer some questions. Maybe a new situation is given in the problem, and you should be able to describe how you might accommodate these visitors. What's important when you're moving the guests is that you can't be sloppy about where they end up. So you can't just say, oh, just ask people to move over to the next room forever. You have to be able to state where each guest ends up at the end of the night. So you can't relocate the visitor over and over with no place that they end up. So I think that was a little bit tricky, but be prepared in the final to answer some of these types of questions. I forgot to mention this when we're talking about the worksheet, but this Grand Hilbert Hotel idea makes it sound like O infinity is the same size, and that is the wrong, that wasn't the point I was trying to get to at all. So infinity is a very flexible concept where infinity plus infinity is still the same size as infinity. And all that stuff could be described using Hilbert Hotel or similar ideas. But there are actually other sizes of infinity out there. We just didn't have time to discuss it in class. So for example, if you're familiar with real numbers, if you include like irrational numbers like square root of 2 or pi and so on, if you consider the set of all possible real numbers, that is a bigger size infinity than all the integers. So there are different sizes of infinity out there. We just didn't have time to discuss it or to prove that. So I wanted to make sure you knew that before we end the class. And then in the back side of the Hilbert Hotel worksheet, we introduced the idea of sequence and series. And in particular, we learned this formula on geometric series. So in particular, if you plug in 1/2 into the R in this formula here, you'll get 1 over 1 minus 1/2, which is equivalent to 2 on the right-hand side. Or in the homework, I think the pizza problem, there was like a R that was a different value, I think 1/3. So if I give you a situation where sequence of infinitely many things that you're going to add is set up in this geometric way, where you're adding different powers, be prepared to be able to compute this infinite sum using this geometric series formula. So if I give you a series question, you should be able to reframe it in terms of this geometric series. So you should know this formula and be able to apply it. In fact, today's worksheet on Zeno's paradox was one such situation where it didn't start with 1, it started with 100, but each of the term you added after that was 1/2 the size of before. And you could look at it as 100 times a geometric series, and then you were able to compute the series and then resolve the paradox using that computation. So understand and be able to explain this Zeno's paradox. And at the end, there was a little bit about dividing by 0 paradox. So dividing by 0 is illegal in algebra because you could end up with nonsensical answers that are just simply not true. But sometimes you can divide by something like a 0, and that idea goes with this idea of infinitesimal, where things are very close to 0, but not quite 0. And then you can make sense of dividing by something close to 0. And that entire idea is the basis of calculus. which some of you have seen, some of you haven't, and that's totally fine. So I think that concludes the main ideas I wanted to I want you to get out of the last 2 units. The final quiz will include some of these ideas, as well as the first 3 units on logic, probability, statistics, and data. The review videos for those, we have, so this is one good thing about video lectures, that you can go back and watch those things to get the review videos again. So I'll link those in the announcement. Okay, so I think that's it. I'll end this video here.